Today's video will explain the class relation of association. Hello, I'm James Helfrich. There are several different ways that multiple classes can be related. Inheritance, nested classes, composition, aggregation, there's quite a few. Today's video will describe association. An associate is a partner or colleague. An association is a connection. Similarly, an association class relation simply means that two classes are joined to each other. Another way to put this is that one class uses another class. For an example, I have a host class and I have two methods, method 1 and method 2. Method 1 takes associate as a parameter and method 2 returns an associate as return value. And so I have the associate class and the related with a horizontal line, and we use an arrow to indicate association. There are several forms that association take. An attribute in a host class, an input parameter of a host class, the output parameter of a host class, and a local variable and a method in a host class. Let's talk about each of those in turn. At a minimum, association relations are represented with a simple solid line between two classes. So once again, we have the host class, and I'm going to have an attribute called composition. Now, composition is an associated class, and we use a horizontal line to represent the related. But now, since this is composition, we're going to use a special form of association, namely composition, and then don't forget our numerosity. Now, we're going to have a pointer of the type aggregation. Now, once again, aggregation is going to be another class and related by association, but the special form of association is aggregation with the open diamond. And once again, we have our numerosity. I need to emphasize composition and aggregation are forms of association. They're just special forms of it. And usually when we talk about composition or aggregation, we don't refer to it as association, we refer to the more specific version. I'm also going to have a method called M1. It takes a parameter of type association 1. So therefore, we're going to have another class called association 1, and it's related with the horizontal line, but the special form of association is the open arrow, which means association. I'm going to have a method called M2, which is going to return an association 2. So there's my association 2, and it's also related by association. And then I'm going to have a method called M3. Now, this M3 doesn't appear to have a class called association 3, but I do have a local variable within that method of type association 3, and therefore it also gets association as well. Now, most often, end caps are added to clarify relations. Also, composition and aggregation usually avoids the arrow to minimize cluster. So I could have my open arrow for composition and aggregation, but it doesn't really add any clarity, so I'm going to omit that. Okay, so there are some notational differences we can use here. First of all, anytime I have a horizontal line, that pretty much means association. Often we add an arrow to indicate which class has knowledge of another class. In this case, host has knowledge of associate. And how does it do so? Well, because associate is a local variable or a parameter or return value. However, associate does not have knowledge of host. It has no idea that host exists. Now, sometimes we want to indicate ownership with a dot. And notice that little tiny dot next to the host. And the UML standard says that dot needs to be tiny, about twice the width of the line itself and no bigger. And what this means is that host creates and destroys the associate, much like composition creates and destroys it. Kind of the same idea here. The final variation you see sometimes is they're not going to have arrows or dots, but they're just going to have text. And this text refers to relationship. In this case, host has many associates, and associate is a part of the host. Now, the most common way to represent association in a UML class diagram is the middle one. We use a horizontal line and the open arrow, and we'll continue with that exclusively moving forward. All right, let's look at an example. A ship, like a spaceship for a video game, has many versions of association. So first of all, I have class ship in C++, which means I'm in a class diagram where ship is the name of the class. I'm going to have a private attribute called P of type position. So in the class diagram, I'll say P colon position. Now, position is a class, so I'm going to say a class. What's the relationship? Well, it's association, but what type of association? Well, since the ship is going to create and destroy the position, it's going to be composition, and there's exactly one. Next, I have velocity, which is going to be just like my position class. It's going to be related by composition. I'm also going to have a pointer to a missile a guide. So I'm going to have a guided missile, which I may have or may not have. So now I'm going to have in my class diagram a missile guide attribute of type missile. But now since I may or may not point to another missile, and I'm not going to create or destroy it, this missile is not related by composition, but rather by aggregation. And how many? Well, 0 to 1, depending upon if I'm pointing to a missile or not. Now, I need to emphasize again, composition and aggregation are forms of association. It's just a special form. I'm also going to have a public method called getStatus. So I'm going to have a public method called getStatus. It's going to return a status. Now notice there's no status attribute. Therefore, this status class, the association is not composition or aggregation. Instead, the relation is association. I'm also going to have a void coast, which takes a time as a parameter. So it's not going to return a time, but it has as a parameter. So I'm going to say plus coast t of type time. Now, both my return type and my input parameter are all forms of association. Therefore, my time class is going to be related to my ship through association. I'm also going to have another method called thrust. This one also takes a time parameter, but it uses an acceleration object. In other words, acceleration is not an input parameter, it's not a return value, and it's not a member variable. Instead, it's a local variable, and local variables also count as association. We can learn more about association in the association section in the class diagram 2 chapter of the software design textbook.